this question? Well, we start this way, which is the square root of I is some complex number which in standard form can be written as a plus bi. So we're trying to figure out what complex number a plus bi is equal to the square root of I. Yeah? Okay. Because again, we're saying the square root of I is some complex number which in standard form can be written as a plus bi. Now starting here, if we square both sides, right, we're going to get this. Well, the left side squared is just going to give us I, and then the right side, this here, when we square it using the binomial square, it's going to become a squared and then plus 2abi and then minus b squared, right? Okay, now I in standard form can be written as 0 plus 1i, right? And so we're going to say that this is equal to, well, here we want to put the real part and then the imaginary part. So that's going to be a squared minus b squared, the real part, plus 2abi. Now, two complex numbers are equal if their real parts are equal and their imaginary parts are equal. And therefore, the real part of the left side, which is 0, will have to equal the real part of the right side, which is a squared minus b squared. And then the imaginary part of the left side, which is 1, will have to equal the imaginary part of the right-hand side, which is 2ab. Yeah? Okay, cool. And now this is just a system of two equations and two unknowns. And so we can solve it, say, by substitution. And so if we use the second equation to either solve for a or b, then we could take that and substitute in the first equation. Now, as I just said, we have a choice of, in the second equation, solving for a or b. So I'm going to solve for b. So we're going to write 1 over 2a is equal to b, and then substitute in this first equation. So this is the first equation, and this is the second equation. So if we substitute for b with 1 over 2a in the first equation, we're going to get a squared, and then minus, it's going to be 1 over 2a all squared, and that'll have to equal 0, because that's what the first equation says. A squared minus b squared equals 0, and that's a squared minus b squared equals 0. Okay, cool. So let's do a little bit of algebra. So now we'll have a squared minus 1 over 4a squared is equal to 0. But this amounts to saying that we have a squared is equal to 1 over 4a squared. And then multiplying both sides of that equation with, multiplying both sides of this equation by a squared, I'm trying to figure out where I write next. Well, I suppose here. We're going to get a to the 4th is equal to, right? Again, multiplying both sides of this by a squared. A to the 4th is equal to 1 over 4. Now, if we take the square root of both sides of this, we're going to get a squared, taking the square root of both sides of this, we're going to get a squared is equal to plus or minus the square root of 1/4, which is 1/2. Now, something squared, and a real number in particular, because remember a and b are real numbers here. But a real number squared cannot equal a negative number, so it's not plus or minus, just plus 1/2. So then a will have to be plus or minus the square root of 1/2. Okay, and this time we'll need to keep both the plus and the minus square root of 1/2. Got it. Now, square root of 1/2 we can write as 1 over root 2, because the square root of 1 is clearly 1, right? Okay, cool. All right, so if that's a, that's two values, positive 1 over root 2 and negative 1 over root 2. And b is 1 over 2a, right? So I don't think we need this anymore. So since b is 1 over 2a, we see that when a is equal to positive 1 over root 2, b is going to be 1 over 2 times positive 1 over root 2. So that is 1 over 2 over root 2. And so b is going to equal root 2 over 2. That's when a is equal to positive 1 over root 2. Remember, saying a is equal to plus or minus 1 over root 2 is the same as when we rationalize it, saying that it is plus or minus root 2 over 2, like that, right? Oh, so when a is positive root 2 over 2, b is also positive root 2 over 2. When a is positive root 2 over 2. And you can do this yourself, but when a is negative root 2 over 2, b is going to be equal to, again, just substitute here, negative root 2 over 2. So there are two answers to what is the square root of I. The two answers are that the square root of I is equal to root 2 over 2 plus root 2 over 2i. That's a plus bi with the known a and b now. Or it's equal to negative root 2 over 2 minus root 2 over 2i. And how can we check that we found the correct answer? Well, square this and square this, and you will see that you're going to get I. Yeah? Okay, cool. That's done. I am done.